So our next session is on fire and future energy systems, and so this is the final of the 4 themes that we'll be addressing. Our speakers are going to be the 3 speakers as follows, and I'll introduce everyone up front here. Thomas Korsell with the SEK, Swedish Electrotechnical Standardization Organization, who's also a member of the board for Brandforsk. That presentation on safeguard future technologies toward fire hazards, giving us that overview. That will be followed by Selena Makowicek, and she is with Uber Technologies, formerly with Tesla, and one of those people I'm familiar with who's done significant work with lithium-ion batteries and other battery technologies. And then our final presentation will be with from Max Rosengren from RISE on the fire and explosion hazard of alternative fuel buses. And I know we were talking beforehand that video, which has been viewed widely, and I think you're going to talk about that, Max, is a very dramatic event that occurred here in Sweden not too long ago. So with that, I want to turn it over to our first speaker, Thomas. And yeah, we do need the microphone. Okay, so welcome, Thomas.
Thank you. So, it works, you hear me? Thank you. I'm pleased to be here. Thank you very much for the invitation. That is not my presentation, I can assure you that. Maybe on the downside. Yeah, I have the... it's just like that. Okay. Much easier than I thought. Everything prepared. So, yeah, I'm coming from the Swedish Electrotechnical Standardization Organization, and I'm the CEO, and that's not why I'm here, because that position, I don't think that is rational to be here. I'm also the chairman of the IEC Technical Committee for Fire Hazard Testing, and I think that is the reason why I'm standing here. My research in this area, I will be honest to you, is not to the public, it's to the industry. I work towards the industries and the big industries, the paper mills, the rolling mills, the mines. And there's a huge difference between fire hazard, fire risks in the industry towards the public fire hazard and fire risks. In the public, we concentrate on people. And trying to extinguish the fires quick as possible. In the industry, of course, we have employees, and the safety of the employees is very, very important. But to stopping the production in a paper mill, they don't want that. It costs about an unplanned stop in a rolling mill can cost $200,000, $300,000, $400,000 an hour. So in the industry they say, okay, let it burn a little bit, as long as it don't affect the production or stop it. So it's a huge difference. We focus on material, machines, buildings, and less on people. Of course, I don't say that the employees and people industry is not relevant. They are, but they are more skilled, they are trained, and they know about the fire risks in the industry. So they are easier to handle. People in the public are more irrational, so to say. They don't do as we say. Employees usually do as they are told. So it's a huge difference. But I will try to summarize in total what we do in standardization. And if I know what will happen tomorrow, I probably will not stand here. So what I will present is a qualified guess for tomorrow, how we work in the electrotechnical area. And you can do a lot of analysis for the future of tomorrow in the electrotechnical area. In IEC, we start with the megatrends and break it down from there. And the biggest, most important companies to analyze things more or less have agreed on those different megatrends. And I don't say every megatrend creates fire hazards, so to say. So we have breaking it down a little bit to come closer to the electrotechnical area. What we see, we have a kind of IT revolution. You know, everything should be digitalized. And that is very important because it gives opportunities, possibilities. And you have heard it before in some presentation also. It's a huge, huge possibility. Energy demand. Yeah, everything should be driven by electricity in the future. And that is also creating a kind of risk. But also possibilities, of course. And on the other hand, we talk about energy efficiency. We need more energy, but we should also save more energy. So it kind of contradictory. But if we go to the next picture, so we see what can be a kind of future that creates some risk in the electrotechnical area. Electrical cars. Everybody knows about electrical cars. They come massive. And it creates a bit of problems. It does. It comes not for free, to be honest. You have huge battery packs. You should be able to connect, disconnect, charger in different ways. You have public charging stations which must be handled in appropriate way. It creates risks. You have cables. You have high current. We talk about for fast, quick charging up to 100 amps, even more. And that's a huge amount of energy. If we go to the more homes area, we have this micro production of energy. We talk about photovoltaics, and we talk about micro wind turbines, for example, that you can build, you can establish on your house or on your summer house or somewhere, and that should interact with the grid that we have, and that creates also a huge problem. What happens if you have these energy possibilities and you have some fault in one of the system? How does it affect these other subsystem? It's a huge problem, so which must be dealt, and it's not easy to understand for normal people how these interact with each other. I read in IKEA in UK are starting to selling photovoltaics for homes. We haven't come so far in Sweden, but I think the next step is that you can, for example, in IKEA, buy photovoltaics for home. And that's a question, do you also buy an electrician, or how do you combine these? I mean, it's not easy. It's not easy. But it will come. And of course, all these together, we have the DC, direct current systems. So the question is for the future, will there be two grids at home? One AC, the one that comes from the mains, and then you have your own DC grid for supplying computers, chargers, and things like that. It's not impossible. And then you have two systems that you need to maintain, combine, and so on. So, and DC current system is a bit more complicated when we talk about fires. And if we talk about high currents, it's not so easy to plug out plugs with high DC currents. It doesn't go through the serial, you know, so it doesn't turn out of itself. Usually you have big arcs, you know, so it's not easy. And it can create problems, but also it gives possibilities. We talk about the smart homes, the connected home. The refrigerator talk with the stoves, which talk with the stories that that they need milk or something, and then you have some special deliveries for your groceries and things like that. So it also gives a lot of possibilities with this new technique and all those sensors that will in the future be built in. Everything talks to each other and you can monitor it. So if you summarize it, you can have some of those challenging topics. So what do we do to meet these challenges? The first thing is you need to think from the beginning. Everything that you add on afterwards costs more money. The design from the smallest piece to the biggest system should be part of each other. Add-on is not good. Historically, we talk about passive fire protection. We say, okay, fine, maybe we can have a fire, but as long as it stays inside the apparatus, the container, whatever it is, it's fine. But with the development of the new electrotechnical devices, they start to cost so much. So people say, I'm not willing to let it burn. So we're going from a passive to an active fire protection. I will show you later on some ways of doing that. And of course, all these possibilities with cheaper equipment also makes a faster development. We have earth circuit breakers for DCs especially. We have overcurrent limitation and energy load controls. We have a lot of sensors building in. So all these together makes a system that hopefully will make the future safer. But it doesn't matter how much we build in. It doesn't matter how good we are on designing. The best and most protective way is information. Information to people. Nothing beats that. I can assure you that. I've done this for many, many, many years. I have designed fantastic things. But as I said, people are not rational. Information is the key factor. Whatever you do. So we talk about IoT technologies. You can measure whatever you want today. It doesn't cost anything, almost. And it will come more and more. When the 5G, the telecom net, will be released next year, you can't imagine the possibilities is open up. You haven't even touched the future, I can assure you. I've been at Ericsson and see. It's tactile, it's reality, you can feel it. It's delays of milliseconds. You don't know it, you don't see it. They make a test, this is out of the scope, but they make a test. They show me, they went from 2G, 3G, 4G and 5G. And they download a very famous movie, Borta med vinden. I don't know what it's in English, but with 2G, it takes, sorry? Gone with the Wind, yeah. With 2G, it almost took 20 hours. With 3G, it took 7 hours. With 4G, it took about 35 minutes. With 5G, it took 6 seconds. Then you can imagine. And when the young people of tomorrow get hold of the 5G, with the interrupt levels built in and things, it will just explode. So the future comes faster than we think of. So I said we're going from a passive protection of apparatus or devices to an active. And the way we do now in the standardization is trying to see if we can implement in the new technology these extinguished bulbs. It's a kind of liquid inside the bulbs, which is temperature controlled. You can have them from 70 degrees to 245, 50 degrees in different sizes. And it reacts more or less momentarily at a certain temperature and just blows. So data centers was the first one require these. Google, Amazon, the huge one, you know, they don't accept fires. Cost whatever it will cost. They don't accept it in the data center. It's too much money. I think most of you flew in through Arlanda, the airport here in Stockholm. Every flat screen you see in Arlanda in the public area are equipped with these. It's a condition for Arlanda to set up those in the public area, to have these extinguished bulbs. So they come. The cost is today about half to €1 of those. So of course, if you do 500,000 or 10 million of samples, of course it will cost a little bit. But the protection, I think, overcomes the cost. These bulbs, just 6-7 years ago, cost about €10. So the development increases very quickly and the price is going down. The next step is to have those also in the smartphones and for the batteries. The batteries in the smartphones, the energy concentration just increases, you know. Everything needs batteries, but no one wants them. Very strange. And it's a big risk. So it will come. This is just a picture how it can look. I have movies also, but I think it's too complicated. So that's what I thought to say. Nothing more, nothing less. Thank you very much.
Hello, my name is Selena Mikołajczyk. I'm at Uber Technologies, and I want to thank you for inviting me to come speak on this topic here today. So I'm going to talk about lithium-ion batteries. That's an area I've been working on for about 20 years at various companies. To give you a sense of perspective, lithium-ion batteries were commercialized in about 1993 by Sony Corporation. And at that point, they used these batteries in some very specialized, very expensive applications. They used them in camcorders, which we no longer buy. But they were, you know, a very small product. They were very expensive. And, you know, that's when it started. And then I was working as a consultant at Exponent, and about year 2000 or so, I started taking jobs investigating fires with lithium-ion batteries. And at that point, these batteries were still very expensive, and they were being used in laptops. And, you know, in 2000, a laptop was not everyone's computer. That was an expensive computer for people who could afford to spend quite a bit. And so you had a battery pack, and it might have 100 watt-hours in it, maybe. And again, it was a fairly modest volume of products. But at that point, the industry started seeing fires. And that's when I started working in lithium-ion battery safety. Now, to give you a sense, you know, that battery pack 20 years ago, 100 watt-hours. Now when we look at large format battery packs, the price of cells has come down, the energy density has gone up, and we talk about installing battery packs that are in the megawatt-hour range or hundreds of megawatt-hours. So if we take a look at recent installations of battery packs, we are at a whole different range, and this started to really penetrate the market maybe 2 to 3 years ago. So this is a picture of a solar plus battery installation in American Samoa. And let's see if I can show. That's the battery pack installation there. That's between like 3 and 6 megawatt-hours of battery pack, okay? It's a big installation. This installation powers the island. It displaced diesel generation for the island's grid power, which is a really profound application if you think about it, because the fire protection industry knows that when you use petrochemicals, diesel generators, those come with their own problems and their own safety risks. And the folks that are working in sustainability also understand the aspects of the petrochemical industry that that are difficult. But now you're looking at an island that has taken itself off of petrochemicals for their grid. And this is a trend that is only going to continue. This is an installation in Kauai, on the island in one of the islands of Hawaii. These are probably about 100 megawatt hours. Again, a huge solar field, big battery packs. This island is working to get itself off petrochemicals for its grid power. And you can see that in areas where access to petrochemicals is difficult, where you have to bring them in on a ship rather than through a pipeline, and even areas where maybe they're more remote and you don't want to put the infrastructure in, suddenly solar battery packs, wind and battery packs, even hydro and battery packs start making a real difference, and people are going to continue this trend, and we're going to see more and more of these installations. This is an installation in Los Angeles. You notice there's no solar field next to this one. What this installation did was it displaced a natural gas peaking plant and natural gas storage. Los Angeles had an issue with high pressure natural gas storage, safety issue. So they started investing in alternatives. One of those was battery storage for power, so that they can support their infrastructure throughout the day. The previous ones I've shown you are they're Tesla cabinets. I work there, so I know about those. But you can see a lot of players are getting into this, and you see various type of installations like this, and you see more and more of these kind of containerized systems as well. These are very big energy storage facilities. They're also very quiet. They don't require any maintenance. They're very cost effective, okay? And so they're going to be very, very popular as we go forward. We're using batteries for our grid storage. We're also using them for our transportation. Now, we all like to look at pictures of burning electric cars. I do too. I wanted to show you, first of all, an electric car that is not on fire. That is actually, that's my Tesla, okay? I own one, and it charges inside my garage every night. So I will show you some pictures of fires with electric cars and lithium-ion batteries. Please understand, I own one of these, and I have enough confidence to actually use one of these consistently. The reason, and the other thing that I want to bring out is the reason we bought this car is not just professional pride that this is my industry and I will support it, but we bought this car because it has profoundly greater safety performance than an internal combustion engine-driven car. Because the battery pack is a skateboard under this car, it is almost impossible to flip this car over, okay? Its performance in crash is also rather remarkable because there's no front engine in place, so the crumple zone on this kind of car is much better. So what you see is, you can look at this from a sustainability perspective, you can look at this from I'm going to get away from petrochemicals, but also from a perspective as an owner, which car do I want to put my family in? An electric car can have a much, much better safety performance than an internal combustion engine car. Okay, so that, again, you're going to see a trend to electric vehicles for a lot of reasons. That are often overlooked, okay, and also from a perspective of safety for first responders, when you respond to a lot of vehicle crashes, you see a lot of injuries. These cars have the lowest probability of injuring the driver or passengers of anything on the road, which is that's a substantial thing, okay. Also. People like to take pictures of burning Teslas, and I complain at conferences when people show pictures of burning Teslas. I'm going to go and show you some pictures of burning Teslas. But fires with these electric cars are much less likely to happen than with internal combustion engine cars, so you should keep that in mind. We're looking at this with cars. We're also looking at this now with semi-trucks. And semi-trucks are very interesting, particularly in the United States. A lot of the cargo around the country is moved by these vehicles. The fuel costs on these vehicles are immense. There's the promise from a number of potential manufacturers to make electric semi-trucks. They cannot produce these fast enough or get the technology out there fast enough. They are being pre-ordered by the industry because of the potential savings in transportation costs. So we're going to see a lot of these. And then this is the future. This is where I work at Uber right now. We're developing electric aircraft, vertical takeoff and landing for air taxis for cities. These are small aircraft. They'll take about 5 people. The battery pack we project in this will be about 150 kilowatt hours. The Tesla I showed you was 85 kilowatt hours. So it's not that much bigger than a battery pack in a car. But this is something that that we see that we're going to have in the future. And my feeling on this is if we can make an electric aircraft like this, there's not going to be internal combustion engine cars on the ground. This is going to be the future. So what do we need to protect? Well, some of the things we've talked about. Energy storage systems, we can have problems with those. The picture you're seeing here is a facility that was in Arizona that about a month ago had a severe incident. There was an explosion. 4 firefighters were injured and taken to hospital, 2 of them critically injured. That's a real issue that we need to address and understand. We need to talk about vehicles. That's the iconic picture that I see at every conference of burning Teslas. I used it too. There are other electric cars that have had fires and people have caught them. They do not happen that often, but at the same time, we do have to be aware of this, and we also have to be aware that, cars, even internal combustion engine cars now, are a little different, and our codes and standards were really written with the cars of the 1950s, 1960s, 1970s in mind. They do need to be updated in general. So we also need to think about our parking areas, our charging areas. We also have to think about production facilities. People are making these battery packs, and there's not very good code for lithium-ion batteries. That's something that NFPA has been working very hard on, also the insurance industry, but it's very difficult to define what kind of sprinkler protection you would use in a production facility. And then recycling infrastructure is a new thing too, that we're seeing. People have recycling plants and they start having fires in them, and they realize that people are throwing their lithium-ion batteries into the trash or into the recycling bins, and that's caused a great deal of loss. And that's something where we have to address as well. Okay. So first step: what should the OEMs, the original equipment manufacturers, do? When you're designing a laptop battery or cell phone battery, all of us have seen the videos of these. They can have a pretty big fire, but it's not that big a fire. Okay. When you take a look at a vehicle or an ESS that catches fire, that's a potentially much bigger hazard. So you have to design those systems with the idea that you will have cells that will go into spontaneous thermal runaway. When I was still a consultant in about 2006, I visited Tesla. I was a consultant, and I looked at their first design, and I said, you're going to burn about 1 in 10,000 cars to the ground. And they looked at me and they said, what do you mean? And I said, well, industry typically sees about 1 in a million cells just spontaneously catch fire. The industry record has gotten better since then. But the problem remains that you do have spontaneous thermal runaway failures that they're not really spontaneous, but they look that way. And so you have to assume if you're going to have a system where you're going to have 1,000 cells in the battery pack, 10,000 cells in the battery pack, 100,000 cells in the battery pack, the chance that one of those cells will suffer thermal runaway failure is substantial. And so you have to design for that. And what you do is you design propagation resistance into your battery packs. To the guys at Tesla's credit, they thought I was a giant pain, but they went out into the desert and burned some battery packs, and they realized, propagation, it's an important thing. And then they started designing for propagation resistance, and they led the industry doing propagation-resistant battery packs, and have been pushing that concept for a long time in the industry. So you have to do that, but then you also have to assume, well, there will be situations where propagation resistance is not enough, where you will overwhelm that for any number of reasons. And at that point, you do need to know how your battery pack is going to burn, and you have to design for that. Because you cannot have a battery pack where if you start an uncontrolled thermal runaway in there, you have an explosion. Okay? You don't want something where cells are going to come rocketing out of your battery pack and pose a hazard to first responders or to try to spread a fire. So you have to also design your battery packs assuming that they will be attacked by fire or they will have a bigger fire. Okay, that's a very important thing for an OEM to do. To do that well, the OEM has to do full-scale testing. And this is daunting when you look at these containerized systems for ESS and you propose to these manufacturers that they take and burn a container. They look at you like you have two heads and they ask if you're crazy. It is a difficult thing, but at the same time, if you don't fully understand what will happen in that container, and that's difficult to do with benchtop simulations, and it's easy to fool yourself with a benchtop simulation to think, oh, I can control this well enough, I know what I'll do. You really need to have burned one of these at some point in time and really understood what will happen. And I think that was probably one of the issues with that Phoenix incident. They had suppression in the container, but they hadn't really thought about what they would do after that fire was suppressed, where it was still smoldering inside, and then eventually someone had to go open the door. And it was after the firefighters opened the door, and they'd been on scene for like an hour, seeing smoke kind of coming out of some switchgear, and they had to open the door, and they wanted to go in and suppress the thing. Well, that's when they had the explosion. Okay, so when you run full-scale testing, you do discover some of these things that maybe you hadn't really thought about beforehand, that then you have to plan and design for. Okay, the other thing an OEM should do is prepare the proper emergency response guides and think about who's going to be responding to my unit and what are they going to do. Sometimes people do SDS. A battery is not really a material, and it's kind of unique. And really, you need to provide the first responders an appropriate guide for how they're going to address your battery pack. Okay. Going along with that is an OEM is really obliged to provide a strategy for removing stranded energy. Okay. If you have a battery pack that, for example, gets damaged, it's involved in a crash, someone runs into a stationary ESS with a truck, a forklift, and they damage the battery pack. Now you have a damaged battery pack that you may not be able to discharge electrically. How do you deal with the stranded energy? How do you decommission that piece of equipment? What's your plan? There has to be a plan. If you don't provide a plan, you're really only doing half your job. Okay? And then finally, you have to have some recycling plans, and really the industry needs to support the standards process for developing some of these more advanced standards. Now, OEMs cannot address this issue on their own. This is something that, we're going to see more and more of these battery packs. And there's going to be a number of low probability events that are going to crop up that, that are just going to have to be handled by the fire service. For example, natural disasters. So this, I don't know how many people remember the Fisker Karma. It was a nice car. It was a very beautiful hybrid electric car. The company had about a little more than 300 of these parked outside of New York City, and the superstorm Sandy occurred. And what that did was it flooded these cars. They got flooded by a mixture of salt water and mud. They were a total loss. They also had a low voltage system that was susceptible to short circuiting, and a few of them, as the water receded, started catching fire. And it wasn't the high voltage batteries that caught fire, it was the low voltage systems that started these fires. Battery kept the power going to the low voltage systems. They had a number of fires. And then they had to dispose of all the rest of these cars, which were water damaged and potentially could have a fire. Okay. You don't have a superstorm that comes through and floods your entire inventory very often, but it does happen enough. High-speed collisions, we test for, there are certain regulatory requirements for collision. There are faster collisions that occur, and just strange accidents that you didn't design for because they were so far out of expectation. Arson. I've seen, I investigated when I was at Tesla. I investigated any number of fires, saw a few which were arson, where someone tried to light the car on fire. It happens as well. Your battery can be adjacent to another fire, and it can sustain heat damage from something else. At that point, you have a damaged battery that you need to address. Something else I saw when I was at Tesla where people were deciding they wanted to try and repair the battery pack themselves, or there were little small companies that were coming in to refurbish the battery pack, or there were hobbyists who would buy totaled cars on the internet and then take the battery packs out and try to create their own little projects for those battery packs. They might be home stationary systems. They might make another car. They might do any number of things. a lot of these people did not really understand the hazards that were associated with the battery packs. It was always terrifying to watch the YouTube videos, and I'm watching them do things, and I'm wondering where the high voltage gloves are, and they're just kind of digging into these battery packs that are 400 volts barehanded. It was eye-opening. Okay, and then we're also seeing something. We're seeing something at Uber with the small bicycles, electric bicycles, that people are stealing the battery packs, disassembling them, and selling the cells on the black market for profit. Again, all kinds of things happen out in the world. People are very creative. So a few questions that I often see from the fire service that I wanted to address with you. The first one is, how does a fire crew know if there's a problem? You come to a site, someone has claimed they smelled something, they saw something. The best indicator is smoke. Okay, a lithium-ion cell is hermetically sealed. It is not sending any gas out to the outside world in normal operation. The only time you have gas venting out of a lithium-ion cell is if it is overheated inside and it is starting to vent. And that vent temperature on that cell, by regulation, by the UN transport regulations, is somewhere above 150 C. So if that cell has exceeded 150 C, you will see smoke out of it. You will not see smoke out of a cell otherwise, unless someone's done something like punctured it. Then you might see some venting things. But if you walk up and there's no hole in the battery pack and there's smoke coming out the top, you know you have a problem. Okay. The other thing you need to be aware of is that smoke is flammable. It may contain it may also contain some fraction of hydrogen, which makes it very ignitable. Okay. This is recently from Shanghai. This was an incident in a parking garage. This was a Tesla that caught fire. You can see the smoke, and then it ignited. Okay. So smoke out of lithium-ion battery packs should not be ignored and should be assumed to be very flammable. The good news is that it is very easy to detect this smoke. A standard smoke detector that you can buy in a hardware store is very adequate to detect that. And it will detect it before you can see it. Okay. That's a full-scale test that we did with NFPA, a power pack, and that's the smoke coming out of that power pack. It's designed to produce the smoke upwards rather than out toward anyone that might be on the ground. Another one is, can we use water? Yes, water is very appropriate for lithium-ion cell fires. It will suppress flames, it will protect exposures, it will cool battery packs if you can get it into a battery pack to actually cool the cells. Sometimes that's difficult. People will periodically want to try to use a lithium metal extinguisher on a lithium-ion battery. That is a very bad idea for two reasons. One is it will not work. Okay, it is not designed for that. And number two, lithium metal suppressants, they work by melting and encapsulating the lithium metal to separate it from its oxidizer. Okay, that's what works with lithium metal. That action can actually make lithium-ion battery fires kind of worse, because if you've got vents and vent paths that you're planning, that your cells are you're planning to have your cells vent through, if you start clogging those with material that kind of melts and starts sealing them, you could have a worse problem than if you just let the whole thing burn. Okay. In some cases, I recommend CO2 extinguishers. For example, in a factory situation, you're building battery packs. You have a lot of electrical equipment. You want people to feel like if they see smoke, they can grab an extinguisher and apply it. It will cool the cells down, and it can give you a lot of time to react in other ways. It's effective. It's not as effective as water. Okay. But something else that we should consider is if you've got a properly designed system, you might consider letting it burn, particularly if you can effectively protect the exposures. And the reason for that is it is substantially easier to clean up a fully burned lithium-ion battery pack than a battery pack with stranded energy. It's substantially easier. Okay, so you know this is a balance that needs to be addressed. Now, some cases you can do that, sometimes you can't. Does the fire pose unique hazards? Yes, it does. Not necessarily the ones people worry about. The smoke that's released from a lithium-ion battery, even when it's smoldering, can be very flammable. And you might have the flame suppressed, but you're propagation of thermal runaway may be continuing and you're producing a lot of smoke that can still be a hazard. So you need to consider that. Depending on how your pack is designed and how your cells are designed, you might have some jetting flames that can occur. If you have a poor battery pack design too that does not constrain your cells, you can have cells that will start rocketing away from the battery pack and spreading fire to surrounding areas and being a hazard to first responders. That's important for designers to continue to consider, and it's something that the Fire Protection Service needs to consider as well. There's a lot of reignition potential. If you've got, again, a properly designed battery pack where you fire blocked to slow down reactions, to make sure that reactions are fire might be well behaved, that will have a tendency to slow down the whole progress of the fire. So you would have lulls of maybe like, you might have a module catch fire, you see flames, that stops for about 15 minutes, and then you catch the next module that'll reignite. And we saw this where, fire service shows up, they see the flames, they apply water, things seem to stop, they apply more water, and then the next module catches fire, and then they suddenly think the water made it worse. The water did not make it worse, but this was the latency that was built into the system. Again, this is why full-scale testing and reviewing full-scale testing in the fire service is so important, because if you haven't seen this before, it is very surprising. Okay. Something that people ask me about is toxicity of the smoke. I've studied that. NFPA has studied that. People worry about hydrofluoric acid in the smoke. From the studies that I have done, you're more likely to encounter HF in electronics fires from the insulation on the wiring than you are out of lithium-ion batteries when they're burning. Some of that's going to be dependent, obviously, on how people handle their battery packs, but this is not something that's a big issue with these. The flames are at regular flame temperatures. The smoke is flammable. That is the biggest hazard. Okay. Next question is, how do we clean up the mess? Usually when you come to a fire, you worry about, suppressing the flames and then doing an overhaul. It's a really bad idea to go with an axe and start trying to overhaul a lithium-ion battery pack. I really, really hope people don't do that. What you have to consider with the lithium-ion battery pack is, can you assess, is there stranded energy, and and then what's your plan to get rid of it? Can you let it burn? Is that your way to get rid of the stranded energy? Can you discharge it electrically? Or what my companies have tended to use is a dunk tank method, where you submerge the battery pack, but you have to then let it corrode in the water. That will take days, if not longer. And dunk tanks have their own unique hazards associated with them. So you have to be careful. You have to know what you're doing if you're going to try and do a dunk tank approach. Now, there's the German fire service posted this depiction of a dunk tank. They took a car, put it on a crane, and then submerged it, the entire car. That's not the way I would do it. Okay. There's some hazards with submerging an entire vehicle and a vehicle which might have a 400 or 800 volt system. Putting the whole thing underwater for a number of days is difficult. There are better ways to do this, okay? But to do this better, you need the OEM's support, and you need the OEM to have worked out how they're going to do a discharge for this, okay? And then finally, you have to consider how you recycle the debris. Even if you've got a burned battery pack, you don't want to be just dumping that into landfill. You want to be sending cell bits to recycling. And if you've used a dunk tank, you take also the water and you treat that as waste appropriately, okay? So just to finish, we're going to see a lot of large lithium-ion battery packs. There's a lot of good reasons for that. A lot of benefits, both for stationary and for vehicles. But they do pose some unique risks, and this is a new technology that we're not used to. Petrochemical industry, we've had 100 years of experience with. We know how to deal with lithium-ion batteries, really the large format ones. We haven't seen these for more than about 5 years. So there's a lot of learning, a lot of training that has to happen in the near term. The OEMs can play a large role in this, and they should. And then my other takeaway is that full-scale testing is very important. As daunting as it may seem, NFPA has led on this. They've run vehicle tests. They've run ESS testing. They've worked with FM Global recently on warehouse and sprinkler testing. There are requirements for full-scale testing in the newest standard for energy storage systems. If you want to go over certain thresholds, you have to do the full-scale testing to prove that you actually understand what the system will do. The biggest hole that I see right now is that the methods for controlled release of stranded energy have not been well established. If you've got a group that's been doing this a while, people know how to do this, but it's not been something that's been promulgated to the industry. Okay? So thank you.
Hello, my name is Max Rosengren, coming from RISE. I work with battery abuse testing, so I know this very well, and I normally talk about that. But I also do a lot of fire investigations. So I will give you an example of a gas bus that was in an incident here in Stockholm, the 10th of March. So it was... we take next. We take a movie here first, so you can understand what it is. See the flames from the gas tank and the safety valves when they venting. So if we take this from the beginning and take details, I get a task to look into this accident from the operator, and they want to find reasons for the incident and how it's possible to come to that end. So I went to Fredriksdal, where we have the operator in this case. Look at the same bus type. It's an articulated 18-meter long bus. It have 5 gas tanks, CNG tanks. They are almost 4 meter long, and they are 400 millimeters in diameter. So 5 of these are on the roof here. There are different kinds of gas tanks, and this is carbon fiber, glass fiber, and a PVC lining. So it's one of the weakest variants of the gas tank. So this day there was a driver. It was a Sunday. He coming in good time to his shift, and should disconnect cables here in the front. The buses are always connected to air and electric, so they already are ready to go. And in this case, he, of some reason, gets stuck with one of the air hoses here, and that was stuck in the mirror. And he backed out, and he didn't see that, so he pulled all of the equipment from the wall down. So he gets a bit disturbed. Now he also get a bit late for his shift. And he also immediately press a button that they have to communicate with the traffic leading area. And that could sometimes be placed in a queue, so you don't get respond immediately. So he started to drive, and he are on the way to the starting point called North Tull. So he need to go to several bridges, tunnels, and so on. And here, when you normally go to that place, you take Herkullesgatan against Klaratunneln. And this is a normal way if you take a car. In this case, he was disturbed. He didn't understand that he have a gas bus. He didn't know that he was high. So he have no clue. So all signs that you will be presented here will be that he didn't understand that he had a problem. So the normal way is to take Söderleden here, and he take right instead, directly into the tunnel. Here is where that is shifting. So here he should go left, but he take the right. And here in the beginning, you don't see any signs or warnings of this traffic place. We take next picture here, and then you see you have these hanging metal cylinders. You can imagine that will be very noisy. But if you see a bus, the bus is, say, in the front 2.5 meters high, and the gas tank is much, much higher. So it means that it will not hit the front of the bus. It will hit 3 meters in to the bus. And if you are in the queue, slowly moving forward, it could be possible that you don't hear that. In this case also, he were then contacted back from the leading, and he started talking at the same time when he driving. You also see things here that read if there are a vehicle that are higher than 3 meters, you will have warning signs lighting up. So you can feel that this must be really good. You also see several 3 meter warnings, and he should understand if he know that he have a higher bus, but he didn't understand that. We continue forward. You see also this traffic place is very interesting. I cannot understand why you put things in front of each other. You have a lot of information. You see already from beginning, it's too much. And you also cover other signs here. The warning signs here, the first two, they are lighting up of this, and it worked. The problem is that there is a delay of 2.5 seconds. So if you drive, for example, in 30 kilometers, which is possible, and you also have this sun protection a bit down, 30 kilometers, you will never see this. You are already past the warning. Very interesting. And the lights here also get red. They are red like 5 seconds longer than normal. Then they went green. So if you still don't know that you are high, you have not seen any more warning signals, it's possible to continue. So he did. Then you have this nice beam that was placed there because there have been so many incidents of buses or trucks and that kind of vehicles driving into this tunnel. I in the latest time here, 20 single cases that have been, and gas tanks have been moved from the roof, from the tunnel roof, so to say, and down, and have gas leakage and so on. So that have been several incidents, and they have not done anything about that. So they put this metal beam in 20 millimeter steel to protect that no gas bus or other vehicle come into the tunnel and create problems. Then you have this equipment that were very interesting. This is a solution they have made to avoid that you cannot communicate to a cellular phone or handheld equipment. So then they put a mic on the front of the steering wheel, on the dashboard, and also bottom. So this is a single-way communication system, a very old one. So you need to press the button to talk and release it to listen. It's also very bad hearing, so sometimes the driver needs to lean forward over the steering wheel to be heard. So that was the case here. So immediately he didn't get this record, but he'd get it in this traffic situation where it was the worst you can have it. So he talked into this when this happened. Then you see the result. I have put frames 1 second between, and there is immediately a mechanical damage on one of the tanks. So they are on the same height, but due to that the road is leaning a bit, one of them is a bit higher. You see the black thing there, that is the one of the tanks starting to fly and loosen from the bus roof. And the hole is like 10 centimeters divided by the width of the tank, so say 400 by 10. And of that, you get propulsion, start to flying backwards, and due to that, there was an opening in the top of it. It start to rotate and go in front of the bus instead. So it's hit the building in front of the bus, approx 15 meters up. And luckily, they have aluminium shed protection in front of the windows. So that protected it from flying into the building, actually. You see, still huge cloud, not ignition yet. But here you see on the right side, we start to get ignition. There are witnesses, there are also other cameras saying that occurring on top of the roof. So what you see here, it's very difficult to see exactly what's happening here. What we see is that the gas was ignited inside the bus first. There was a boom, press out the front window of the bus, the door was open in the front, and luckily for the driver, he could escape at this time. And he was protected also by the plastic behind him. So he burnt his ear severe, and also the left hand, because he held in that bottom. So, and then he had taken out the gloves that they normally have. So that was not protected. So he burnt these two. But I mean, amazing that he managed. We can also see here, if there had been passenger in this bus, probably everyone had been dead. That is the scary thing. And then you see also the cloud outside was correct mix, and also the next pressure wave start. So it's a huge fire. So this is the result afterwards. A lot of damage, totally burnt. You see still 2 gas tanks on the roof. 4 have fallen in to the bus, and 1 have flown away from the bus. And that is lying here on the pavement. Here you see the damage and the hole in that tank that was loose, and here you see that still are on the bus, and you can see that the beam have also touched and make almost hole to this tank also. So it's very lucky that only 1 tank was in this incident. So a summary of what we find in this investigation. Of course, we find a lot of different things. But the driver, he of course is obliged to understand the height of the bus. He must understand what kind of route he must drive. In this case, the training was a problem. He was not trained as they say it should be done. So due to that, he was a bus driver for another company or operator. He gets a short way to start driving. So I don't say that is the reason. That might be one possible pieces. The communication equipment here, of course, that also create a bad situation. Bad hearing, you need to concentrate, press, leaning forward. Not good at all. The run-in protection beam in steel, is that the best solution? If you kill people outside or inside a tunnel, I don't know. For me, it's very strange to have that kind of stop. They could also be easily solved with traffic lights. If you keep it red, take the stop that you have possibility to fall down, then it could not be moved until you have support and take the bus from that. So it's very easy to solve it. And we see on these traffic places here in Stockholm, there is no risk analysis. So it could be whatever. It seems that the last incidents steer what you will see. So there are more and more signs all the time. So it's very interesting. So there's some of the findings. So I have a short and quick presentation here, but hopefully you have some view of this incident. And this is as normal a statement that fit in also here. Thank you.
So could I ask Selena and Thomas to join Max up on the stage? So we are a little bit into our break. We could take maybe one question, quick question if possible. Yeah, if you want to.
Yeah.
Yeah. So and Thomas, you want to join us up here?
Thank you.
So is there one? Oh, right here, Bjorn.
A question to Selena. We know about this. I'm from Rice also, so we know about these explosions that can occur on batteries. They are spectacular. But I also know that the vehicle industries, they are very careful. You know, cars are safe in many ways. But also these battery packs, they now tend to go to buildings, to support buildings. And then you're in another ballpark, because buildings are generally not so safe as cars are. So, and the power of a battery pack like that would be enough to blow up a house, maybe. So, do you have any thoughts about this? What could be the future when these things move into buildings?
Yeah, that's been an issue of concern for the fire protection community in general. A few years ago, the fire in the U.S., there was a movement to change the fire codes and change threshold limit values, or threshold limits for how much battery you could put into a given building. And they've now done that. So there's a limited size you can put in a residence, some limited places you can have this in a residence, and then also a limited size that you can put in a commercial building. And then there is in draft and in final kind of final process, a new standard from NFPA 855, which addresses installation of ESS and looks at different situations where if you're going to talk about putting a battery pack in a building or adjacent to a building or in an area that's well populated versus something that's very remote. And if something is very remote, you have a little more leeway. You can decide, right? At the same time, you can decide, maybe I let it burn. But if you've placed something out remotely that's going to be responsible for the grid power for your city, you probably don't want to let it burn, because if you do, you suddenly don't have any power, right? So at that point, there's a balance there between how you construct this thing for resiliency, right? So, yeah.
I have a good thing. I have seen Tesla batteries are taken in modules and are sold to solar panels to private persons here in Sweden. That is very common, and Tesla cells are protected mainly by the BMS system. You have these strings also, I know that, but the cells in itself is built in another way than normal. So it means that the protection that you normally have in the car that is really good is not in that solar panel. BMS. So it's very interesting.
Yeah. And
Yeah.
and I just
I've
want to
seen it.
clarify, you know, you use the term OEM, the
Yeah.
original equipment manufacturer,
Yeah.
and the term I often hear is the aftermarket,
Yeah.
where people are doing things beyond
Yeah.
what it was originally
Yes.
designed
Yeah,
for.
I also look at this. People say, oh, can we just mount a Tesla battery pack or a Leaf battery pack on a wall and call it an ESS? And I think that's a terrible idea. Those things were designed to be underneath a car. They're designed to handle loads that you would, crash loads that you would find underneath a car. They are not designed to be hanging on a wall and deal with those kind of crash loads. So, it's one of those things where when you look at a UL listing, for example, for an ESS, you can list something. That means you've tested it and you've made sure that it's appropriate for the application. And I think the aftermarket is a little behind on this.
Yeah. But this is also crashed cars where they pick these batteries, so it's really crazy.
Yeah.
So we are in our break time, but we'll take one last question over here.
Thank you very much. Jim McLaughlin from the UK Fire Protection Association. Thank you for two very, very good talks indeed. Actually, the final comment is really what I want to talk about. In the UK, the police are really at a loss for how to deal post-crash with electric vehicles. They haven't been on fire, but they are damaged, often wheelless, and generally they get handled very roughly, winched many hundreds of meters onto the back of a loader and then off. And I think the current guidance really asks for them to be sighted 50 meters from anything combustible afterwards, which just simply isn't achievable. Does anyone have any good guidance out there?
Yeah, actually, I wrote that 50 meters.
Right.
I wrote
Okay.
Tesla's ERG and the guidance on that. And the intention there is to, quarantine something until you can get it out to get a service team out there to assess the battery pack and then discharge it. Right. A lot of times on a crashed car, if your electrical system is still working, you turn the heater on and it will drain the battery pack very quickly, right? And the problem solved. If you've got something where you've disconnected the battery pack, you need a service center to come out and try and drain the thing for you. Those are usually fairly straightforward things to achieve. A lot of times the OEMs have a difficulty negotiating between the insurance company, the OEM, the service center, who's supposed to show up when.
Yes,
Right.
we actually represent insurers, and there's a concern that some of the activities to make the car safe essentially financially write it off because the battery pack is one of the most vital and expensive parts of it.
Yeah, I know. The insurance companies like to sell the battery packs from crashed cars. They put this on eBay, and because they're trying to regain their value. Meantime, the OEM would much rather you just scrap that.
Yes.
Right. That's a tension that has to be worked out.
So we are during our break, and I just will add, by the way, in
Yeah.
support of all three presentations in that last comment, that we often find ourselves focusing on the high severity, low frequency event, but the high frequency, low severity event should not be overlooked as well as we go forward with these technologies. But I want to thank all three speakers. Thank you very much. They were excellent presentations. We have an item.